Hello, and thank you for joining us. On behalf of Trout Software and Caresoft, I would like to welcome you to our webinar, CMMC for Legacy Equipment, Practical Compliance for Machines and Industrial Systems. At this time, I'd like to introduce you to our speakers for today. We have Florian, who is the founder and CEO of Trout Software, and we have Mark, who is the head of Mission Ready at Trout Software. Mark and Florian, take it away.
Hi, everyone. Thank you for coming, and thank you, Caresoft, for having us. CMMC for legacy equipment. CMMC, obviously, been a big topic these days. Lots of concerns about it, about when it's coming out, what's happening, who it applies to, some ambiguity on deadlines, people concerned about cost, time, resources, all of that. Um, as of the end of last year, it's launched, and so we want to dive into some of the specific problems with it, specifically how legacy equipment ties in with specialized assets. And so, who's this for? This is for the manufacturers, the depots, machine shops, um, any prime subcontractors, really anybody in the defense industrial base and supply chain. And we want to focus on those that are navigating the issue of how to secure their legacy equipment. And essentially, if the equipment's older than your your intern, this webinar is for you, is what we're saying here. So,
Sounds good. So why we're having this conversation, specific conversation? So CMMC expects tight control when it comes to access control, monitoring, or boundary defense. And the idea is that this is quite easy or quite something that you can achieve in the IT world, where you look at some of the systems that tend to be all fragile or always on that you cannot unplug, or where there's low vendor support, it becomes way more challenging. And CMMC and NIST, which is the framework underneath, basically recognize that problem with the notion of specialized assets. Specialized assets are exactly these that you cannot move, you cannot patch, so you need to find boundary or alternative protections on or around them that needs to match the intent of the legislation when it comes to CMMC. So CMMC, we're going to talk a lot about today, and we're tackling both level 1 and level 2 when it comes to legacy and on-premise system. In a few words, so I'm Florian, I'm the CEO and co-founder at Trout. I'm a former security engineer at Google, as well as a Harvard cybersecurity graduate, and I'm a CMMC registered practitioner too.
Mark. I'm Mark, Defense Programs Lead at Trout. I'm also run our Mission Ready program, which is tailored towards small manufacturers. Prior to this, most of my background comes from the military, where we're majority of time in Special Forces, where I worked in tactical communications and cyber and operations. So we're going to dive into today some of the real challenges CMMC. That can mean many things, but for a big one that's been coming up is with these specialized assets and how to secure them properly. We're going to touch on VLANs. VLANs is probably a term that you may have heard thrown around there, and you may have some in place. And that's a virtual local area network, and how that is plays into your security footprint, and essentially when they're great things to use, but not quite enough to meet compliance. And then we'll do some discussions about what on-premise enclave is. You may have heard the term enclave, specifically when it comes to controlled and classified information, CUI. And we'll dive into that, and we'll do a bit of a demo as far as what that could look like, and a way to create that solution. And then we'll close with some Q&A. Okay, so what are specialized assets? Before we go too deep, let's anchor the conversation a little bit where we talk about what the actual standard is, so we're all on the same page there. So under NIST 800-171 and CMMC 2.0, the systems we're talking about are formally recognized as specialized assets. That's what CMMC 2.0 and NIST calls them. And the government has to give everything an acronym, so they are also called SPAs. You may see that as well. But to quote CMMC 2.0, CMMC defines specialized assets as systems that are part of a CUI scope, but are not capable of meeting security requirements directly due to their operational nature, technical limitations, or impact on mission or production. So, some key takeaways from that are that specialized assets are part of a CUI scope, so they can still be used for CUI, but they don't meet the requirements for CMMC compliance directly on their own. So you have to have some indirect protections in addition to surrounding them. And that's what we're going to get into today. So some examples of some specialized assets that may be familiar to you would be your CNC machines, your PLCs, HMI, uh, test and measurement systems. If you have an on-premise server that has customer data, or especially any plans, or definitely any CUI, manufacturing instructions, your maintenance terminals, really anything that you'd be deemed operational technology or Internet of Things devices.
Yeah, so touching a couple of points as mentioned, specialized asset may handle QE. That's I think that's one of the relief for many people. They are in scope when it comes to the CMMC assessment, which means that you need to document them precisely and describe how you protect them. So those alternative protections that we've mentioned. What is interesting also is that CMMC and expects you to not necessarily to modify them, to change them, or to rebuild to specialized assets, but really to have this security that matches the intent of protection that we're going to discuss right now. And I think, Mark, you had the slides up, so happy to jump in there. Basically, we categorize the intent of protections in 5 pillars, which is what you're aiming to achieve for any assets. And then when it comes to specialized asset, it's really how you need to benchmark the alternative solutions that you can put in place. The first one is about visibility. Everything starts with visibility. It's the ability to understand what's on my network, what devices they actually who is accessing them, and kind of those network behaviors. That's really the first pillar that's there. From there, it's a pillar around access control. How I make sure that the right person are accessing it in the right way with the right protocols and the right protections in place. And I'm able to monitor that over time, which is one of the other pillars. The third one is around encryption, making sure that when QE is floating or moving through my environment, it is encrypted both in transit and at rest. At rest on an SPA can be challenging sometimes, but at least in transit, we need to think about this encryption as the QE is moving around. Monitoring and logging is a bit something I mentioned earlier. It's really how you get the logs, the proof of the system, so that whenever an audit or audit time comes around, you're able to show some of the proof that you have. And in a more unfortunate environment, if you have an incident and you need to do some incident response, so that you're able to do some forensic, looking at who accessed it at what time, and kind of trying to pivot from there to your different system. The last one, which is the funniest of all, or at least the one everyone loves, is about documentation and justification. So really, it's about building in your SSP a clear definition of each of your SPA, what are the protections in place around them, so that you fall into the fifth intent pillar of CMMC.
Yeah, so this is no doubt a lot. It's a lot to think about for each individual asset. That have their own unique um, specialized problems with the specialized assets. And depending on the amount of folks that you have working for you, it's a lot for an IT department, it's a lot for management to keep track of all this. So a really efficient way to meet all these 5 pillars for each individual machine in your entire network would be to establish the secure boundary of your SPAs, your specialized assets, instead of just upgrading a machine. If you have, say, a legacy machine that you're having a hard time with, we don't want you to just have to replace that machine. Especially if it's still working. It's been your baby for a long time, and it's still a workhorse. We want to avoid that if we can. So what we do is we create a boundary around that machine, but with the security controls that are needed. That machine of itself does not have. So what I'm talking about here is I'm introducing this concept of the enclave that I mentioned when I was talking about the agenda, if you've heard about that. So think of your enclave as your boundary of where there's the enclave boundary of where the actual CMMC work is being done. So the portion of your network that has those machines that's doing this CUI related work or has CUI on it, that needs to be identified, and you want to have that scaled to be only as big as you need it. And within that enclave, you have essentially micro enclaves. So think within the big bubble, you have small bubbles around each individual asset.
Yeah, and to piggyback on that, really, this notion of micro enclaves is close to things like micro segmentation. That's always or often used in networking, which is how you can reduce the footprint, the lateral movements by rethinking the network and really cutting into smaller pieces, which ties exactly with the next kind of pillar we want to talk about, and VLAN as a potential solution. So VLAN is a technique or a technology that most people that have worked in networking are familiar with. It's just a way to segment some partition of the LAN, or on the most of the time in the internal network. It's a great segmentation tool. It's a great traffic optimization technology. And you can build some lightweight documentation around that. Often we see VLAN as a way to categorize assets. So, for example, I put my cameras on one VLAN, I put my specific OT or my IT on one VLANs, and it's used as really this segmentation, a logical segmentation of the physical machine. What's interesting is that if you look at the 5 pillars we mentioned, VLANs are pretty poor solutions when it comes to identity and ensuring that the right people have access to the information. So kind of tying authentication and identity. In terms of encryption, it is not something that the VLAN per se can do because it's a layer 2 construct. So it's really just the pipe on how the data moves. It's not looking at the data and making sure that it's encrypted. And finally, in terms of audit trails, which is kind of monitoring and logging, the information that you have at the VLAN level is pretty weak, and something that's really difficult to use when you're doing forensic or to try to prove your compliance posture at the time of an audit. It's quite of a challenge there. So stepping back, really, you achieve some of the goal, which is segmentation performance as well as documentation. But when it comes to visibility, access control, encryptions, and monitoring, it's score quite low, and it's not really the best in class or the only solutions that you should have in place to protect your SPF.
Yeah. So the VLANs are great, and we see that a lot where they have them in place, and it's great organization, and they're doing their best with them, but it's doing a great job isolating that network and isolating different areas within the company, essentially creating enclaves, but they're not enforced enclaves. They're not creating enforcing identity. They're not logging, and they're not creating that zero trust environment that we're going for, which the zero trust environment being that all connections are deemed untrustworthy until they've been authenticated. So VLANs are an awesome start, but they are also just often used as a bandage rather than a solution, which can help. But when it comes to actually getting the compliance that's needed, it's not going to do the trick entirely.
I think we have a tab, a recap
Yep.
on the next one, right?
I'm sorry. Yeah.
It shows that bit. So that's another way to look at this, but it's pretty much what we mentioned. When you look at the different pillars, it fits the bill on some of them, the documentation, but not really on the rest, even though documentation is still manual. So what we wanted to pivot is kind of on the solution on a better ways to achieve CMMC and the five intent pillars of protection for SPA, which is around leveraging proxy technology and as well as those micro bubbles or enclave that Mark mentioned as a level of protections and to achieve some of them. I think we have a graph in the second one. First, before we jump, in terms of ensuring identity with VLAN, some people might have tinkered with 802.1x, which is a way to create authentication before accessing the VLAN. It is usually really painful and a long integration. So that's why if you've embarked on that journey and you have some pains, there's still time to move somewhere else. And if you haven't yet, maybe talk to people who have done that journey. It tends to be pretty large and costly at scale to implement and maintain. So moving away from the VLAN and really focusing on security with a proxy. The idea here is to create a proxy in front of your machines, which means that instead of having your specialized assets directly on the network and being able to interact with the other elements, with the WAN also directly, you put kind of a modern small proxy in front of it where you can push the IT control that you would expect. So when it comes to discovery, when it comes to role-based access, encryptions, or monitoring and logging, everything is realized with the proxy that sits in front of your core machine of the SPA that sits behind. So the idea here, when you look at this diagram, is to capture kind of the pain point about this approach, which is I am not going to install in front of all my SPAs a small device. This is not achievable, and that would create downtime. So what we're doing at Shroud is the ability to deploy one on-premise appliance. You can think about it as kind of it's a network appliance that you connect to your firewall, your router, or your existing switch. And it's then able to use software-defined techniques to inject those proxy in front of your different SPAs or even your on-premise systems. And the real value here is that you have a plug-and-play device, simple to connect on the shop floor. And then you have all the agility of software-defined networking that allows you to move things around while being really granular in terms of production. So if we now step back and kind of look at the five pillars that I think we're on the next slide, and we kind of rank again. So with the proxy that's sitting in front of my SPA, I have full visibility into what the SPA is doing, what protocol they're using, who they're talking to. So I can really enforce that micro enclave around the SPA or at the SPA level. When it comes to access control, and we'll be able to do a bit of show and tell or to show that in the demo in a couple of minutes. But the idea is that the proxy can act as a gate so that you can manage authentications and so on before allowing the second step or second leg of the communication and really having a strong and integrated access control capabilities into your broader technology stack. Mm-hmm. When it comes to encryption, this is pretty advanced at the same time because as you can run a modern IT proxy, you can ensure TLS tunnels or TPS, communication up to the device and really push that encryption on the network really further as far as you can, and that's achievable. And the final one is about monitoring. So as this proxy is acting as the middleman and seeing all of the traffic, the authentications, and what behaviors are or actions are realized, then it's able to capture all that information, either for analysis on the access gate on the device, or to stream that back to a log sync or CM system, which meets one of the requirements of CMMC, which is I want to be able to see my data and then do some forensic and then being able to analyze all of my assets over time and what happened to them. So that's kind of the scorecard in terms of the 5 pillars. Documentation is still a bit up in the air because at the end of the day, it falls really back on the human to do the SSP or to automate that process. Um, but you should capture or better sense that the proxy technology is a better protection to achieve CMMC for SPA in that regard.
So to bring that back a little bigger, so what we're doing here before we get into the demos, we're deploying a plug and play box into an existing network, which identifies all connections, and it serves as a proxy for all of those assets that are on that network, uh, and creates that zero trust environment um, for the entire network and at the machine itself with that bubble. So the micro enclave within the big enclave, the little bubble within the big bubble we were talking about, and but not in the cloud. This is still doing it on premise with the existing network that's in place. So this is the ability to create the zero trust environment with the on-premise assets and network without having to do any recabling at all.
Yeah. And so there's no agent to install. It works air gap. So there's a few nice feature that comes with it. Yeah. Let's jump in a quick demo. So sharing. I'll share my screen over here. And you should be able to see my screen right there. Great. So here, what I'm displaying on my screen and showing is the admin interface of the access gate. So again, the access gate is a device you plug on the network. And there's a couple of ports that you can configure in a different way. Usually when we do an install, we start with configuring the monitoring port, which is the UI I'm showing you now. So it's just like ingesting NetFlow from the network, from the router, and then from there is able to tie that to an asset inventory. So quickly you can identify what are the assets that are unknown and add them to your inventory. So let's say this is my network or temperature sensor. And then dynamically it's going to be added to my asset inventory. So visibility and monitoring the asset is the first pillar, allowing you to move into the asset inventory. So here, the asset inventory is kind of a richer view where you can deep down, for example. So here we have the assets that we just created, able to see where it lives, the type of MAC address, for example, it has, so that you have this physical identity that you can provide, as well as to see the services that it's consuming. So that serves really as the base of, I know what's happening on the network. I can consolidate that at a time and say my inventory at that time was this. And then whenever there's a new device or there's a new behavior, I receive an alert that kind of update or not the asset inventory on that with that form. So once you have this visibility and the monitoring, the capability of the technology is to move into the enclaves. And that's kind of what Mark was explaining earlier, is that you have this big QE enclave, which is this is everything that's going to touch QE at one point. And then you're able to get really more granular and say, these are the couple of machines, or this is the specific machine I want to manage. So in this case, I can create an enclave and do type it more. For the purpose of the demo, set a security level, and you're also able to share that with different sites if you want. And that's going to create basically secure tunnels across those sites. So once my enclave has been created, I can then head over to it. It's over there. And the principle of the enclave is that you can bring users. So let's do, for example, some members of our team, and then some assets that we see in there, or for example, the server that we have in there. And then you're moving into this kind of matrix format that allows you to be really granular when it comes to access. So if I want to give Anastasia in our team access to the specific server, I can grant access in one click, and I can get more granular also. So allow VPN access, for example, or requiring that the users sign a policy or an agreement before accessing a specific device. Once that's done, the UI is reflected. And so you have this simple way of managing access at scale. Because when you need to go back to a specific enclave to grant access or remove access, it's quite difficult to go back to your VLANs and understanding how you've been configuring them or someone else has been configuring them. Versus this one is a bit more user-friendly and direct in terms of my users, my machine, and what I want to allow in there. Of course, you have also history tracking. So whenever there's a change, there is an access that's granted. This is something that we can capture, and that fits kind of the monitoring and logging pillar that we mentioned. For the user, the way it looks like is that if Anastasia wants to access that specific service, she'll access a policy like this through a web URL. She signs in with the authentication that the company has been decided. So, for example, Microsoft 365 is a big integration that we see. And so the users accept, do their authentication through Microsoft 365, where you can have MFA or second factor of your choice of your global policy. And then the access is granted for the period of time that we set in the access screen. So here, the access screen, which is the same thing I showed you on the other time, allows you to define the exact policy you want to display to the users, how much time you want to give them access on it. This is quite important, especially this access timeout, because what we see is that over time, networks tend to be a bit more porous, permissions tend to be a bit wider than they should be. And so the idea of that the system kind of locks down doors behind people after a certain period of time allows to really reduce the security risk, as well as the potential access that they would still have. So here we're kind of closing we've discussed the monitoring, which is the visibility, the enclave, which is the access control that allows you to get granular while being user-friendly. Asset end users are being the asset inventory and the ability to manage the system over time. The last piece of the puzzle, or one of the last piece of the puzzle, is this notion of collection. And as mentioned, basically the access gate allows to get the information on the log from the different proxy, to enrich them with the context of authentications, of elements that you would have on your asset inventory, and then forward that to a log sync, to a CM, to your MSP for incident response. So it becomes really a way to extract the information from SPA or on-premise systems that don't necessarily have this capability per se, and you don't want to build pipelines and maintain them over and over for all of the different systems that you may have on site. So that's kind of the tour really about access gate and how that technology allows you to cover the pillars that we mentioned earlier. So it's about visibility, it's about controlling the access. Encryption is something that we've seen as this is the proxy that maintain the TLS encryption on tunnels, as well as logging and monitoring in a unified and centralized basically device that you can install inside.
Yep. So big highlight of that.
Side,
Yep.
or?
Yeah, I can switch to sharing here. But we definitely want to highlight there the ease of that deployment, the flexibility that it creates in the network visibility. And I want to show you what that looks like. So something we come across a lot, or we hear from manufacturers and businesses that are trying to achieve this, is that they're essentially hearing that they need to secure a lot more than they need to. So it goes back to creating that boundary. And this is a depiction of what that would look like within the network, of what the enclave would look like that's actually doing CMMC related work, where you're picking the machines and the process flows for that CUI. And it's something that you can manipulate and change according to how your business is developing. So whether it's by user or by device, if you have a machine that needs to come offline, needs to be allowed to have maintenance that can be scheduled for an authorized user. If you have an employee that either changes departments or leaves the company and no longer needs to have access to the machine or to that account, you can uh, quickly change their permissions or get rid of them entirely. That's a major security risk. It's caused all kinds of breaches throughout history. We can read all kinds of horror stories of it, of just the account that was left active that shouldn't have been, or somebody that shouldn't have had that. So this is just a way of a visual of what that would look like.
One element that's interesting technically around this is really where you can see the power of software-defined networking, which is with this approach, there is no changes to the wiring, to the VLAN. So we keep the layer 1, 2, 3 in the OSI model, and we really work more on the IP/proxy above, to be able to reconfigure the network based on the permissions or the need of the business. So we keep the physical element, and then we work more on the logical layer that sits on it.
So we often see as well that there's various forms of businesses that all need these CMMC requirements, or and even more than that, that just need to bolster their cybersecurity infrastructure. And it comes from everything from very small, simple networks that could be the equivalent of essentially a home network to some pretty robust and dynamic enterprise environments where the the goal is the same, is to secure those specialized assets in the network and to get it there as efficiently as and effectively as possible. And so the goal by deploying this proxy software defined networking is to essentially take that business from wherever they are and to leapfrog them into that dynamic zero trust environment without having to do a massive physical infrastructure overhaul of the entire network. Take what you have and secure it as it is, and be able to manipulate that.
Yeah. That's one of the biggest fantasy of IT team is the willingness to rebuild the network, or when you start fresh, you say like I would have done this differently, but the reality is that we work with inheritance, we work with what's there, and by using this software defined layer, that's a way to deploy the new network or the new protection with microsegmentations, with those micro enclave directly in it. What one thing that's interesting also that you could maybe see in the demo is that proxy, your access gate, and all this technology gives you a path to migrate over time. So it's not really a switch and replace. Like you're not changing everything overnight and hoping everything works the next day. You have a path to migrate your site over a couple of days or a couple of weeks, depending on the size of them, with less risk and be able to roll back to what exists. So that's usually also a really powerful tool in that regard. There's just one question about I don't see where access gate includes encryption on the wire. So one thing that I can show you in the demo basically, and I'm sorry, I'll
Sure,
kick
go
you
ahead.
again, Mark, but there is one element that you can configure basically in the settings. So here we're really going into the pipes of the access gate, and you have this PKI management. So that's where you can load specific keys so that you enforce TLS tunnels between any device and the access gate. And so all these are encrypted or on the wire, as that was the question. And the last part, which is the pass between or the physical wire between the SPA and the access gate, that's the part that is not that you cannot upgrade because of the capabilities or the lack of capabilities of the SPA. But everything up to the proxy is something that you can protect. One use case that's really interesting in that regard is that when you think about PQC, for example, and what it will entail for physical network or for network where you have those old machines that are definitely not going to be able to handle those type of keys and encryption, having those modern proxy in front of it is a way to be ready also for some PQC down the line. Hopefully that answers your questions, and happy to tackle more in case. cut your flow.
Don't worry about
While you bring that up, I can tackle this one. So yes, you can switch machines on and off. So there's a couple of things that you could do there. There's switching on and off the access to a given enclave. So you say, for example, a user, a group of users, you can block them with one click. And you can also remove an asset from a specific enclave. So let's say that you were using a specific CNC or a server for some QE works, but now you have switched to another one. You can just remove that specific machine from your enclave, and it will stop all of the access that you have granted previously.
This was just to bring it back to that SPAs are difficult to replace, and we don't. They're difficult to protect, and we don't want you to have to replace them if you don't have to. And they can't do all of this themselves. This is what we were talking about, how they can't meet the compliance themselves with what they have on them because the technology wasn't there when this machine was deployed. But we can still create that enclave around it that has all of these features that are required. And we're back into the Q&A.
So for the Q&A, happy to talk about the concept, the architecture, or even the demo. So we'll turn over if there is any question.
How is building this enclave in a Microsoft environment to meet CMMC level 2?
So I'll rephrase just to make sure I understand. So how we build this enclave in a GCC environment? Was that a question? Okay. So here there is two concepts that are important. So GCC or GCC High, which is the recommended cloud solution to host QE and to work on the Microsoft ecosystem, is a cloud solution. So really, you're storing the data on Microsoft servers, and then you have Microsoft teams handling the servers, their maintenance, and the networking and everything. What we're really talking about today is what happens when the QE is on site. So you have machines, you have servers on site that are storing this information. How do you protect them? And that's the core of the technology that the Access Gate deploys. So whenever you have a cloud option, GCC High, that's what's recommended. And then when it's on premise, which is often where you see these specialized assets, so these old machines that are legacy but also essential. This is where the Cloud Access Gate focuses on. Do you agree? Or...
Can-
Do you want to read this one?
Yeah. So for teams that know they need better visibility in their OT environment but aren't sure where to start, what's the biggest mistake you see when we see them make early on, and how can they avoid it?
I think there is a couple of the biggest mistake is not starting at all. So I think once you already have an understanding of like OT is connected, this is a footprint I should secure. It's already in the right path. One of the technical challenges that we see is often deploying technology that is extremely noisy. And some sensors or some alerting system, when you deploy them, can throw a bunch of alerts and then push really an IT team or the people that are supposed to handle them under too much noise so that it's really useful. And that's particularly true with OT and SPA that are by definition vulnerable, that are running old, unpatched services or protocol. And so just deploying a sensor, for example, or a detection, whether it's like an endpoint or a network sensor, is going to create a lot of noise that makes it really, really difficult to treat this information and to move forward as a posture. On the other side, the good practice is really thinking about the network, thinking about let's see what happens between my asset, who's talking to what, and kind of getting an understanding of the lay of the land, which is quite challenging already.
Yeah. So kind of too extreme sometimes, where sometimes it's either just kicking the can down the road and waiting until it's absolutely time to play catch up on the security requirements, or sometimes it's jumping way to the extreme of something that maybe they don't need or may not be best for them. So again, there we are. There's questions here. This one.
So the question here that Mark is showing is, can you switch machines on and off in the enclave, and what does that look like? So I think I answered quickly, but I can also show you exactly what it looks like. And then here you should be able to see my screen. So the idea here is that I can go into an existing enclave, and if I want to block an access, for example, I can, well, here I'm allowing it, and then here I'm blocking it. So Lavania's access to the backup server has been cut in one click. And again, there is an history of all of the changes that have been done, which is something really important when you come to CMMC. So one of the questions that we can see here is, so is this micro-segmentation tool that is deployed on premise? So there's a lot of great concepts in micro-segmentation, which is really how you segment the network into small bubble. So there's a lot of this. Usually micro-segmentation is done purely on the network, and so you're not running a proxy. So micro-segmentations will allow you to define a small segment and to kind of isolate an asset. But then you need to ensure that there is something in front of it, around it, or wherever you want, that is able to do the visibility, the access control, the logging of the access, and so on. So microsegmentation per se is just this idea of reducing the size of the network, which is great, but you need an orchestration between the different zones and an ability to log these or to encrypt these. That is a bit more, that is what the access gate provides. So it ties into the microsegmentation, but it's a bit more evolved than just purely VLAN-based segmentation.
Mm-hmm. And what strategies do you recommend to customers who need to operate a hybrid environment where only some VLANs move to the overlay?
That's a great technical question. So the way the technology of proxy and software-defined networking works is this notion of overlay. So you're not changing the underlay network, the current IPs and the structure of the network that exists, and you're creating this modern overlay on top and migrating the assets whenever you need to or whenever you want. In some environments, you need to keep the network as is, and that's totally fine. The idea, and that's one of the slides that Mark mentioned, is that you can keep most of your network, your structure, and just move the QE work or the specific SPAs and machines you need for the duration of the job over the QE network, and then move them back after. So really, it lives on top of what exists today, and it's just a way to match those 5 pillars that are the intent of CMMC in that regard.
Mm-hmm. And how does Access Gate handle large scale deployments with thousands of industrial endpoints and many enclaves?
Yeah, so this is a great question in terms of scalability. So usually when you look at thousands of endpoints, you have a few gigafactories where that's the case. Most often it's around multiple sites. And so that's why you have with Access Gate the ability to tie different Access Gate together, which create a secure mesh between them. So if you have a massive factory, you can deploy several Access Gate, and then if you have several build or different sites, you can deploy an Access Gate at each of them, and it's going to create this mesh or this connectivity across different sites and way more assets. So that's really the purely physical scalability of the technology that we can achieve this way, and then the rest, the asset, the users, and the enclave can span across of the mesh that you've created, which becomes really interesting and powerful.
Yeah. So you could think of that as a larger scale version of essentially that bubble within the bubble that we made, with the micro enclave of securing that specialized asset within the larger secure enclave. And then you have an even larger secure enclave of the site itself with multiple sites of those that are in creating that larger secure mesh network that Florian's talking about.
A quick question, or is this software built by Trout and or white label? So this both the hardware and software are built and manufactured by Trout. We build all of the hardware also in the US, as well as service it from here. So yeah, this is a US made solution.
Can you ship the access audit and audit logs to third-party centralized logging systems?
Yeah, so that's a great question. Usually, that's the case when it comes to having a CM or MSP that's outside. That's totally the case. That's why I displayed quickly these collection capabilities. So these are you can connect these pipelines basically that are built in to your different systems, whether they are a Sentinel running in the cloud or an Elasticsearch running on-prem at your MSP. What usually we see is pushing a syslog and rsyslog as the go-to format to ingest log. But that's exactly the intent of the device, is that you can stream all of these logs wherever you want to a third party, for your forensic, for your incident response, and your overall strategy.
We quite often have folks that are using their MSPs that will be using this information.
Mhm.
Okay, let's see here. If I'm using a VDI enclave solution to communicate my CUI, can I attach your access gate to that and envelop my legacy manufacturing machines into your bubble? And will that make it all still CMMC level 2 compliant?
So that's exactly what it does. That's the exact principle, is that you can complement kind of your communication tooling, whether using a Prevail on top of your email or a VDI situation, so that on premise around your SPA you enforce the CMMC requirements and extend your system this way. So yes, and great question.
More coming in here. Let's see here in the webinar chat. Well,
There's one question I think that, do you have to sanitize machines when you take a machine off the enclave and put it onto the main network? Um, so here, what's important is that the data that is on the machine that's at rest lives in the machine. This is not something the access gate can control and can really enforce. So yes, when you're finishing a QE work or task, it is better to sanitize the equipment. And that's a recommendations, whether they're staying into kind of an enclave or moving out, is that between work and task, you should sanitize the equipment so that whenever, if, for example, there is maintenance coming, or you have another employee that's accessing the device is clean. And if ever someone needs to access the information, they log in again, they download the correct plan, and you have the traceability that comes from this. So yes, you should sanitize the machine. It's not something the access gate does by default, but that's a good practice in your overall strategy and SSP. There we go.
Did we get everybody here? Thanks. All right. Okay. If there's any last minute questions, fire away. But otherwise, we are Trout. Let me get back to that. I'm Mark. This is Florian, and thank you so much for coming to this webinar. Super important topic that has picked up a lot of attention these days, and appreciate all the really great questions. And can see some of our information there. And please reach out if you have any more questions. And thank you so much, Caresoft, for having us.
Yeah. Thanks, everyone.
I am just seeing one more question in the chat pod. What is the adoption and support level offered for using your product? Does your support resources, are your support resources located in the US?
Yeah, so the team is based in the US, and we support from the US. Usually, when it comes to implementation and support, we also integrate, or there's a conversation which is, what is your current IT partners or MSP, because they have this a role whether to deploy, to support, or to know that the tool exists. So purely our team is based in the US, able to implement and support, but we usually discuss and interact with your existing IT partners and MSP, just to make sure that everyone is aligned and that we bring the right people in the room.
Thank you so much. Thank you, Caresoft. Thank you for everybody attending and for the participation.
Thank you again to Mark and Florian for speaking today and presenting. Thank you to all our participants for joining us today. We hope you found the webcast informative and helpful to you and your organization. Our contact information is currently at the bottom of the screen. If you have any further questions or would like to request more information, a meeting, anything like that, please feel free to contact us. Thank you again and have a great rest of your day.